A prototype is an early sample, model, or release of a product built to test a concept or process or to act as a thing to be replicated or learned from. It is a term used in a variety of contexts, including semantics, design, electronics, and software programming. A prototype is designed to test and try a new design to enhance precision by system analysts and users. Prototyping serves to provide specifications for a real, working system rather than a theoretical one. In some workflow models, creating a prototype is the step between the formalization and the evaluation of an idea. The word prototype derives from the Greek pyro omega tau omicron tau upsilon pi omicron new prototypon, primitive form, neutral of pyro omega tau omicron tau upsilon pi omicron sigma prototypos, original, primitive, from pyro tau omicron sigma protus, first, and tau upsilon pi omicron sigma typos, impression. Basic prototype categories. Prototypes explore different aspects of an intended design. A proof of principle prototype explores some functional, but not all, aspects of the intended design. A form study prototype explores the size and appearance, but not the functionality, of the intended design. A user experience prototype captures enough aspects of the intended design that it can support user research. A visual prototype captures the size and appearance, but not the functionality, of the intended design. A functional prototype captures both function and appearance of the intended design. It may be created in with a different method and scale from final design. Differences between a prototype and a production design. In general, prototypes will differ from the final production variant in three fundamental ways. Materials. Production materials may require manufacturing processes involving higher capital costs than what is practical for prototyping. Instead, engineers or prototyping specialists will attempt to substitute materials with properties that simulate the intended final material. Processes. Often expensive and time-consuming unique tooling is required to fabricate a custom design. Prototypes will often compromise by using more variable processes, repeatable or controlled methods, substandard, inefficient, or substandard technology sources, or insufficient testing for technology maturity. Lower fidelity. Final production designs often require extensive effort to capture high-volume manufacturing detail. Such detail is generally unwarranted for prototypes as some refinement to the design is to be expected. Often prototypes are built using very limited engineering detail as compared to final production intent, which often uses statistical process controls and rigorous testing. An example of a lower fidelity or low-fi prototyping technique is a paper prototype. These can be used as a tool for discussion. They are commonly used for early testing of a software design, and can be part of a software walkthrough to confirm design decisions before more costly levels of effort are expended. Characteristics and limitations of prototypes. Engineers and prototyping specialists seek to understand the limitations of prototypes to exactly simulate the characteristics of their intended design. It is important to realize that by their very definition, prototypes will represent some compromise from the final production design. Due to differences in materials, processes and design fidelity, it is possible that a prototype may fail to perform acceptably whereas the production design may have been sound. A counterintuitive idea is that prototypes may actually perform acceptably whereas the production design may be flawed, since prototyping materials and processes may occasionally outperform their production counterparts. In general, it can be expected that individual prototype costs will be substantially greater than the final production costs due to inefficiencies in materials and processes. Prototypes are also used to revise the design for the purposes of reducing costs through optimization and refinement. It is possible to use prototype testing to reduce the risk that a design may not perform as intended. However, prototypes generally cannot eliminate all risk. There are pragmatic and practical limitations to the ability of a prototype to match the intended final performance of the product, and some allowances and engineering judgment are often required before moving forward with a production design. Building the full design is often expensive and can be time-consuming, especially when repeated several times. Building the full design, figuring out what the problems are and how to solve them, then building another full design. As an alternative, rapid prototyping or rapid application development techniques are used for the initial prototypes, which implement part, but not all, of the complete design. This allows designers and manufacturers to rapidly and inexpensively test the parts of the design that are most likely to have problems, solve those problems, and then build the full design. This counterintuitive idea that the quickest way to build something is first to build something else is shared by scaffolding and the telescope rule. Engineering sciences. In technology research, a technology demonstrator is a prototype serving as proof of concept and demonstration model for a new technology or future product, proving its viability and illustrating conceivable applications. In large development projects, a testbed is a platform and prototype development environment for rigorous experimentation and testing of new technologies, components, scientific theories and computational tools. With recent advances in computer modeling, it is becoming practical to eliminate the creation of a physical prototype, instead modeling all aspects of the final product as a computer model. An example of such a development can be seen in Boeing 787 Dreamliner, in which the first full-sized physical realization is made on the series production line. Computer modeling is now being extensively used in automotive design, both for form and in function, especially for improving vehicle crashworthiness and in weight reduction to improve mileage. Mechanical and electrical engineering. The most common use of the word prototype is a functional, although experimental, version of a non-military machine whose designers would like to have built by mass production means, as opposed to a mock-up, which is an inert representation of the machine's appearance, often made of some non-durable substance. An electronics designer often builds the first prototype from breadboard or stripboard or pathboard, typically using DIP packages. However, more and more often the first functional prototype is built on the prototype PCB, almost identical to the production PCB. As PCB manufacturing prices fall and as many components are not available in DIP packages, but only available in SMT packages optimized for placing on a PCB, builders of military machines and aviation prefer the terms experimental and service test. Electronics prototyping. In electronics, prototyping means building an actual circuit to a theoretical design to verify that it works, and to provide a physical platform for debugging it if it does not. The prototype is often constructed using techniques such as wire wrapping or using verboard or breadboard, with the result being a circuit that is electrically identical to the design but not physically identical to the final product. Open-source tools like Fritzing exist to document electronic prototypes and move toward physical production. Prototyping platforms such as Arduino also simplify the task of programming and interacting with a microcontroller. The developer can choose to deploy their invention as is using the prototyping platform, or replace it with only the microcontroller chip and the circuitry that is relevant to their product. A technician can quickly build a prototype using these techniques, but for volume production it is much faster and usually cheaper to mass-produce custom-printed circuit boards than to produce these other kinds of prototype boards. The proliferation of quick-turn PCB fabrication and assembly companies has enabled the concept of rapid prototyping to be applied to electronic circuit design. It is now possible, even with the smallest passive components and largest fine-pitch packages, to have boards fabricated, assembled, and even tested in a matter of days. Computer programming. Computer science. In many programming languages, a function prototype is the declaration of a subroutine or function. This term is rather C++ specific. Other terms for this notion are signature, type and interface. In prototype-based programming, new objects are produced by cloning existing objects, which are called prototypes. The term may also refer to the prototype JavaScript framework. Additionally, the term may refer to the prototype design pattern. Prototype software is often referred to as alpha grade, meaning it is the first version to run. Often only a few functions are implemented. The primary focus of the alpha is to have a functional base code onto which features may be added. Once alpha grade software has most of the required features integrated into it, it becomes beta software for testing of the entire software and to adjust the program to respond correctly during situations unforeseen during development. Often the end users may not be able to provide a complete set of application objectives, detailed input, processing, or output requirements in the initial stage. After the user evaluation, another prototype will be built based on feedback from users, and again the cycle returns to customer evaluation. The cycle starts by listening to the user, followed by building or revising a mock-up, and letting the user test the mock-up, then back. There is now a new generation of tools called application simulation software which help quickly simulate application before their development. Extreme programming uses iterative design to gradually add one feature at a time to the initial prototype. Data prototyping. A data prototype is a form of functional or working prototype. The justification for its creation is usually a data migration, data integration or application implementation project and the raw materials used as input to an instance of all the relevant data which exists at the start of the project. The objectives of data prototyping are to produce a set of data cleansing and transformation rules which have been seen to produce data which is all fit for purpose. A dataset which is the result of those rules being applied to an instance of the relevant raw data. To achieve this, a data architect uses a graphical interface to interactively develop and execute transformation and cleansing rules using raw data. The resultant data is then evaluated and the rules refined. Beyond the obvious visual checking of the data on screen by the data architect, the usual evaluation and validation approaches are to use data profiling software and then to insert the resultant data into a test version of the target application and trial its use. Scale modeling. In the field of scale modeling, a prototype is the real-world basis or source for a scale model, such as the real EMD GP38-2 locomotive, which is the prototype of Athene's locomotive model. Technically, any non-living object can serve as a prototype for a model, including structures, equipment, and appliances, and so on. But generally prototypes have come to mean full-size real-world vehicles including automobiles, military equipment, railroad equipment, motor trucks, motorcycles, and spaceships. As of 2014, basic rapid prototype machines cost about $2,000, but larger and more precise machines can cost as much as $500,000. Metrology. In the science and practice of metrology, a prototype is a human-made object that is used as the standard of measurement of some physical quantity to base all measurement of that physical quantity against. Sometimes this standard object is called an artifact. In the International System of Units, the only prototype remaining in current use is the International Prototype Kilogram, a solid platinum iridium cylinder kept at the Bureau International des Poids et Mesures in Chevreuse, France that, by definition, is the mass of exactly 1 kilogram. Copies of this prototype are fashioned and issued to many nations to represent the national standard of the kilogram and are periodically compared to the Paris prototype. Until 1960, the meter was defined by a platinum iridium prototype bar with 2 scratch marks on it, the International Prototype Meter, and in 1983 the meter was redefined to be the distance in free space covered by light in 1,299,792,458 of a second. It is widely believed that the kilogram prototype standard will be replaced. There are 2 likely replacements. One is a definition of the kilogram that will define another physical constant to a defined numerical value, thus obviating the need for the prototype and removing the possibility of the prototype changing very slightly over the years because of loss or gain of atoms. The other definition is using a system that finds the amount of force needed to counteract the pull of Earth's gravity on a 1 kilogram artifact. Natural sciences. In many sciences, from pathology to taxonomy, prototype refers to a disease, species, etc., which sets a good example for the whole category. In biology, prototype is the ancestral or primitive form of a species or other group, an archetype. For example, the Senegal bichir is regarded as the prototypes of its genus, Polypterus.